Good morning, everyone. We are the Group 1 and we present to you what is soil chemistry. By the way, my name is Clarence Barandino and I'm here today to present to you about the soil chemistry, the soil colloids, and the properties of colloids. This is our the pointers to discuss the soil colloids, properties of colloids, properties of soil clays, cation exchange capacity, base saturation, the soil solution, soil pH and acidity in soils, effects of aluminum on soil acidity. So, what are the main components of soil? The four components of soil include mineral water, 45%, organic matter, 5%, air, 25%, and water is 25%. So, what is soil chemistry? Soil chemistry is the interdisciplinary branch between soil sciences and chemistry and studies the chemical characteristics of soil. Soil is made up of the solid particles and water, air, microorganisms, and plant roots contained upper layer of the earth crust, which is caused by erosion of the rocky subsoil. The soil chemistry can therefore be regarded as a part of the field of geochemistry. The soil chemistry concerned with the chemical composition and chemical changes of these layers. Especially of interest are the chemical properties of the soil, such as the composition of the different soil types and layers, the exchange operations, delivery and absorption of nutrients, ion exchange, base saturation, the pH value and buffering. Soil colloids. How soil colloids are formed? There is a constant process of exchange going on, with cations attached to the surface of the clay or humus particle being released into the soil solution, where they can then be taken up by the plant root. New cations then become attached to the colloid. The soil colloids are very small organic and inorganic particles present in the soil which are the responsible for potential fertility of the soil, determine the physical and chemical properties of the soil. First one, how soil colloids are formed. As soil is formed during weathering processes, some minerals and organic matter are broken down to extremely small particles. Chemicals changes further reduce these particles until they cannot be seen with the naked eyes. 2. Types of soil colloids. Soil colloids may be inorganic colloids and organic colloids. In organic colloids, clay minerals, layer silicate clay, iron and aluminum oxide clays, allophane and amorphous clays. Inorganic colloids includes highly decomposed organized matter called humus. Organic colloids are more reactive chemically and generally have greater influence on soil properties.
Good morning. My discussion is all about the types of soil. Soil is classified into four types: sandy soil, slit soil, clay soil, and loamy soil. And I will discuss the different types of the four. What is sandy soil? So sandy soil is the small particle of weathered rock. Sandy soil are also one of the poorest type of soil for the growing plants because of the very low nutrients. The second is the slit soil, known have much smaller particle compared to the sandy soil. And also, slit soil is the made up of rock and other minerals particles, and it's also used into the agricultural practices to improve the soil fertility. Clay soil is the smallest particle among the other types of soil. The particles in the soil are tightly packed together without an earth space, and clay soil is also the densest and heaviest type of soil. The soil is also referred to as the agricultural soil. The same for the slit soil. For the instance is the ability to retain moisture and nutrients. Ang video na to ay makakatulong sa iyo para mas maintindihan pa lalo kung ano talaga ang pagkakaiba ng apat. Upang mapanood ang video, ay pumunta lamang sa description box.
Properties of colloids. Colloids, a homogeneous non-crystal substance consisting a large molecule or ultramicroscopic particles of one substance dispersed through a second substance. Properties of colloids and their variation are a well-known area ever since the primitive age. The best example to prove their familiarity with us is that knowing from very early time that coagulation of milk results to the formation of simple term, we can define colloids as a mixture where one of the substance is split into very minute particles which are dispersed throughout a second substance. The minute particles are known as colloidal particles. Physical properties of colloids. The nature of colloidal solution is heterogeneous, i.e., unlike those solution dewy with two different phases. The two different phases of colloids is dispersed medium and dispersed phase. Dispersed medium. The continuum medium such as gas, liquid, or solid in each a dispersed phase. In distributed LA, so-called continuous space or internal space. Dispersed phase is the one of the two phases of colloids. The dispersed phase is discontinuous space, thus that is distributed throughout the dispersed medium. The dispersed phase is composed of particles that has diameter around 1 to 100 nm. Next is the difference of dispersed medium and dispersed phase. Dispersed medium, this is the continuous phase of uncolloids, known as external space. For example, water in milk. Dispersed phase is one of the two phases in colloids, discontinuous, known as internal space. For example, dust particles in air.
Begin to the first, the electric double layer, or also known as the structure of electric field interface. Electric double layer theory. Charge is imparted to the particles by placing ions, which are absorbed preferentially at immovable points which for the first layer. So in 1850s, Helmholtz started the electrical double layer model, and this is the importance of electrical double layer model. First, structure of double layer influences the kinetics of the electrochemical reaction. Next, aids to understand and explain the mechanism and rates for redox processes. And lastly, it is responsible for many properties of the given system. This is the example of structure of electric field interface. As we can see, it is have a two layer, the diffuse layer and the stem layer. Under the potential energy curve have three components, the surface potential, the stem potential, and the zeta potential. As we can see, the positively charged particle, which is called hydrodynamic plane of shear or the sleeping plane, and lastly, the negatively charged particle. The next properties, electrophoresis. It is the process in which an electrical field is being applied to colloidal solution, which is responsible for the movement of colloidal particles. Depending upon the accumulation near the electrodes, the charge of the particles can be predicted. The charge of the particle is positive if the particles get collected near a negative electrode and vice versa. This is the example of electric field, electrostatic force, and the friction force. And lastly, the electroosmosis. Electroosmosis, it is the process in which the sparing medium of a colloidal solution is brought under the influences of electric field and the particles arrested. This is the example picture of electroosmosis. As we can see the positively charged and the negatively charged, and the volts to create an electricity. And that's all, the electrical properties of colloids. The electrical double layer, electrophoresis, and the electroosmosis.
Properties of soil clay. Soil structure. In perfect garden soil, there is a mixture of sandy particles with clay particles with decomposed organic matter. In clay-rich soil, there is a little organic matter. It is organic matter that supplies nutrients and allows the root of the plant to climb through the soil with a little resistance. If clay particles are so close together, it can be difficult for roots to travel through the soil. The clay, however, is, is rich in minerals and its stickiness prevents erosion. Add, Adding organic matter to the soil year after year will eventually result in improvement for clay soil. Clay. Clay is a common name for a number to fine grain, earthy materials that become plastic when wet. Chemical. Chemically, clays are hydrous aluminum silicates, ordinarily containing impurities, potassium, sodium, calcium, magnesium, or iron in small amount. Benefits. The mineral the minerals and moisture retaining qualities of heavy amount of clay in soil can be a benefit. When high clay soil is combined with other types of soil, it can be the one of the best compounds of vegetable or flower garden. The hardest part is just reaching the perfect amount of organic material since the clay soils tend to overpower the organic material.
Cation exchange capacity. Soil nutrients exist as positively charged or negatively charged ion. When dissolved, the positively charged ion are known as cation and the negatively charged ion are known as anions. The nutrients which exist as cation are calcium, magnesium, ammonium, potassium, hydrogen, sodium, aluminum, iron, magnets, zinc, and copper. Some of the nutrients which exist as anion are chloride, nitrate, sulfate, phosphate, borate, and moldate. Cation exchange capacity is a soil chemical property. It is the ability of the soil to hold or store cation. When soil particles are negatively charged, they attract and hold on to cation. Positively charged ion, stopping them from being let down the soil profile. The cation held by the soil particles are called exchangeable cation. On the other hand, negatively charged soil particles repel ions negatively charged ion. The implication of this is the negatively charged nutrients such as nitrates, sulfate, and chloride are vulnerable to leaching the soil profile. As a CEC measures a soil ability to hold nutrients. It is a key determinant of soil fertility. Soil which high CEC have the ability to hold more calcium, making them supplicant in calcium, magnesium, and other calcium, or on the contrary, soil which low CEC are actually easily deficient in calcium. Soil with high CEE have high ability to hold water, clay soil, while soil with low CEE have low ability to hold water. Soil in the low CEE group typically have values. Soil in the high CEC group are greater than 10 mg and 100 gram. Soil with low CEE become acidic very quickly. For example, sandy soil, and would need liming more frequently than soil with high CEC.
What is base saturation? Base saturation is basically the study or knowing what are the important nutrients of your soil, or in agriculture they use it to know the four major components of what your soil is and the nutrients it has. To discuss it further, it is the sum base of cations. These four are the major ones: the CAMG, K, and Na. Calcium, magnesium, potassium, and sodium. Held onto the soil exchange, size divided by the total CEC and expressed as a percentage. What is CEC? CEC is cation exchange capacity, and advocates the BCSR maintain that there is an approximate ratio of basic cations that must occupy the soil CEC or plant growth will be limited. And what is BCSR? It is the base cation saturation ratio. Next would be percentage of CEC occupied by bases of the nutrients mentioned earlier. It is always measured in percentage. And with the increasing soil pH. What is soil pH? Soil pH is basically the basicity of your soil. The higher it is, the more alkaline it has, and the lower it is, the more acidic it is. This is a figure of an example of soil pH. Yes. You want it higher, obviously, so you want your soil more nutritious, or containing more nutrients, something along the line.
The soil solution. Definition. Uh, the soil solution is the medium in which surface and solution reactions occur. This aqueous solution contains dissolved matter from soil chemical and biochemical processes and from exchange with the hydrosphere and biosphere, Freeze and Cherry, 1979. Then water moves through the soil in response to potential energy. Then what is soil solution? The liquid phase of soil, water with dissolved gases, minerals, and organic matter that reaches the soil after passing through the atmosphere and percolating through the soil horizons. The solution may be in a film, capillary, or gravitational form depending on the moisture content of the soil. Then, what is the depth of soil? Soil, the unconsolidated mineral or organic material on the immediate surface of the earth that serves as natural medium from the growth of land plants. The upper limit of soil is the boundary between soil and air. Shallow water, leaf plants, or plant materials that have not begun to decompose. Then
Solution. The soil solution depends upon the soil moisture and may be gravitational capillary, or film-in form. A soil solution contains ions that are released by minerals and organic matter. These ions are primarily nutrition that plants are able to grow up through their roots and carry to the stem and leaves. Through a process known as mass flow, the soil solution continuously moves toward the roots as the plant takes up water.
Soil pH and acidity in soils. Soil pH is a measure of acidity or alkalinity. The degree of soil acidity or alkalinity is expressed in pH units. Soil pH affects many processes in soils, including nutrient availability, activity of microorganisms, and root development. The pH of natural soils typically ranges from 4.5 to 8.0. Soils with pH below 7.0 are acidic, and soils with pH above 7.0 are alkaline. Most plant nutrients become available at slightly acidic pH of 5.8 to 6.5. The effect of soil pH on nutrient availability. At a soil pH lower than 5.2, nutrients such as calcium, magnesium, nitrogen, phosphorus, and boron may become unavailable for plants, while the solubility and availability of trace elements such as iron, aluminum, manganese, zinc, and copper increases significantly, and they may become toxic. In highly acidic soils, the mineralization process of organic matter is slowed down and can even stop completely because microbial activity declines under low pH conditions. This results in a decreased availability of nitrogen and phosphorus. In high pH soils, micronutrient deficiencies become common. Phosphorus availability is reduced in both highly acidic soils with pH lower than 5.5 as well as in alkaline soils with pH greater than 7.5. In acidic soils, phosphorus reacts with iron and aluminum and becomes unavailable, while alkaline soils, phosphorus reacts with calcium.
Effects of soil acidity. Plant growth and most soil processes, including nutrient availability and microbial activity, are favored by a soil pH range of 5.5 to 8. Acid soil, particularly in the subsurface, will also restrict root access to water and nutrients. So, no, lahat naman siguro tayo nagtatanim sa lupa. Lahat ng tinatanim nating halaman, mostly sa lupa natin yan tinatanim. Nandyan din yung mga microbial activity, pati yung mga dumi. Nakaka-apekto kasi yun sa paglaki o pag-growth ng ating mga plants na tinatanim. Soil pH. Soil acidity is measured in pH units. Soil pH is a measure of the concentration of hydrogen ions in the soil solution. The lower the pH of soil, the greater the acidity. pH is measured on a logarithmic scale from 1 to 14, with 7 being neutral. A soil with a pH of 4 has 10 times more acid than a soil with a pH of 5 and 100 times more acid than a soil with a pH of 6. So yun, no? Kapag mas mababa yung volume ng ating soil, mas prone siya into acidity. Mas malaki yung epekto niya.
Aluminum toxicity. When soil pH drops, aluminum becomes soluble. A small drop in pH can result in a large increase in soluble aluminum. In this form, aluminum retards root growth, restricting access to water and nutrients. Poor crop and pasture growth, yield reduction, and smaller grain size occur as a result of inadequate water and nutrition. The effects of aluminum toxicity on crops are usually most noticeable in seasons with a dry finish
as plants have restricted access to stored subsoil water for grain filling. Figure 1. Al- aluminum concentration or as the aluminum concentration ay as the soil pH drops, the aluminum concentration increases, and as the pH of soil decreases, the aluminum toxicity is also decreasing. Uh, in the figure 2, it shows the difference of roots. The other one has aluminum of 2 milligrams per kilogram, and the other one has aluminum of 15 milligrams per kilogram.